Hello and welcome to our event on communications in process industries, on communication with field instrument in process industries. I want to start with a brief look on where we are today in communications with field instruments in process industries. And just to start with, the operation of the process plant is not the issue. Today we've got very reliable ways like 4 to 20 milliamps or field buses to communicate the process data, to use the process data. However, there are some challenges, especially if you want to use modern technology in the plant. Engineering is pretty complex. What we're seeing in process automation are many different protocols depending on the vendor, on the application, on the system that is used. This means that gateways are needed to transfer or translate between the different protocols. The engineering of such gateways is complex, especially because the data formats between the different ways to communicate are inconsistent. And last but not least, it's pretty difficult sometimes to get hold of the right device drivers for the instruments that are used, so like DTMs and device packages. Technicians that are upkeeping the plant are required to work on more instruments in less time, to get more efficient. But what they find is that they've got limited access to the data in the instruments that they are needing for troubleshooting. Sometimes they even need to walk up to the instrument to connect in handheld. Also, plant operators are expecting today the data that is needed for maintenance and optimization aggregated in one place. Typically, that's referred to as the cloud. However, usually in today's architectures, there's no access to data in instruments, and if at all, it is a nightmare to configure the access to that data. One example to show a little bit that dilemma is the effort that is needed in big data analytic projects. And what you see here is a typical example, the distribution of time and effort for a big data analytics project. So about 40% of the effort is taken to do data processing, to capture the data, to get the right domain knowledge. Another 20% is needed to provision the data itself, and 40% are used to analyze the data and create the right models to interpret the data. And that shows that about 60% of the effort doesn't add any value to the analytics of the data. So what we really need is that data is available instantly, just like electricity from an outlet. End users are working on initiatives how to get better access to data, how to implement the Industrial Internet of Things or Industry 4.0. And I want to highlight two initiatives. One is the NAMO Open Architecture. In that picture you see the automation pyramid, and next to the automation pyramid you see the maintenance and optimization layer. And NAMO Open Architecture is looking into concepts how to get the data from the automation into maintenance and optimization without interfering with the plant operation. The Open Process Automation Forum is working on a complete new architecture for process automation. And both initiatives are working towards simplification of construction, commissioning, operation, optimization, maintenance of process plants. So optimization throughout the life cycle of a typical process plant. What does this mean now for automation? Today, what we see is the classical automation pyramid that has communication throughout different layers, between different layers of that pyramid. And each layer has distinct communication protocols. Where does this lead to? Sooner or later, we will have no choice than ending up in a flat communication infrastructure that is replacing the hierarchical infrastructure or system we've got today. It will be an infrastructure that allows each instrument to talk to each instrument, each node in the network to talk to each node. Ethernet is the enabling technology for such a flat communication architecture. Ethernet is nothing new. It originates from 1973 when Bob Metcalfe from Xerox proposed it for the first time. So it's been really a while ago since this has started. Today in IT and even at home, Ethernet is the absolute standard. Just imagine at your home, probably your printer will be connected using Ethernet and not a dedicated interface like the old Centronics or USB port. In manufacturing industries, Ethernet has made its way. It is state of the art for communication. Why don't we see that in process industries? There are very good reasons. Process automation has a different environment. Plants are huge compared to factory plants. Just imagine a distillation column, I don't know, 30 meters tall, or the fact that we see quite frequently explosive atmospheres in process industries. And also our users are used to have two wires to connect an instrument rather than having separate cable for data and power. This translates in some pretty special requirements for process automation. Actually, one of the most important is we need to support intrinsic safety for protection in explosion hazardous areas. We need to support long cable runs. We need to have loop power. That means power and data on the same cable, on the same pair of wires. Connections need to be ruggedized. Process plants are frequently outdoor. And we also need robustness against electromagnetic interference. All this translates in our vision for a uniform communication infrastructure in process industries. No gateways, no proxies between different networks, between different field buses, means a flat communication architecture, high bandwidth, much higher than today to allow new functionality in devices. Our clear vision is that IP-based, Ethernet-based communication on all levels will become the enabling technology and state-of-the-art for Industry 4.0. And that means we will get open access to all field device data. And that also means that field devices other than today will be multi-protocol capable. That means they will be talking the appropriate protocol for the application that is needed. So like one protocol to do communication into the process control system, process values, and a different protocol running at the same time to communicate into the cloud to do maintenance and optimization. So what are we doing now to make that vision come true? We are working on Ethernet-APL. There was a meeting in Hanover in 2011 when a number of vendors in process automation talked about the future of communication with field instruments in process industries, and we came to the result that we are all sharing that vision. And from 2011 on, we've been working on that in an informal team, and that ended up in 2018 in a project that involved the most important vendors in process automation and very importantly also all the organizations, the user organizations that are working on standardization in communications in process industries. In 2015, we had the first working demonstrator that showed that we can transmit power and data with high speed with Ethernet protocols over a long line to communicate to field instruments, and that this all can be done with intrinsic safety. So we showed one physical layer that transmits anything, any protocol, and powers the instrument at the same time. Another important milestone was reached in 2018. It was the first time ever that there was a joint presentation, a joint demonstration of the three user organizations, Profibus International, ODVA, and Fieldcom Group. There have been working demonstrators on many booths of industry partners in that project as well. What is the vision now? How does that translate into a field device? So one aspect is the self-contained device, as we call it, that is supporting the entire life cycle of the instrument and the process plant. It will automate daily tasks like self-instantiation on the network. It will report a detailed status during operation. It will provide complete documentation like manuals, installation drawings, certificates, declaration of conformity, device descriptions, and so on. So all that data will come embedded in the device and can be downloaded from the device. No need to search for it on the internet anymore. It will allow direct and parallel communication. As mentioned before, it will allow to talk to the control system at the one side, and on the other side it will be able to talk to maintenance and optimization systems, or it will allow to look into status data for people that are doing maintenance on these instruments. Since it's Ethernet based, it will allow direct communication. There will be no need for gateways. There will be no need to configure any kind of such functions. How can you get hold of the data? How can you access the device? Actually, in future, that will be from anywhere. Technologies today allow that, to connect to devices from a control room, from a handheld devices through the internet. The missing link is the physical layer that connects the last mile to a field instrument in process industries. And that's what we are working on with Ethernet-APL. I hope I made you curious. I welcome you to join our remaining presentations where you will learn much more details on Ethernet-APL and Also, please join our sessions where we talk about Ethernet-APL, where we answer questions, where we answer your questions. And I hope you will enjoy the rest of the day together with us. Thank you very much.